Today we are going to discuss about our next topic, that is network devices. So what do you mean by network devices? Am I audible to you? Is my screen is visible?
Yes,
Yes,
sir.
sir.
Okay. So in the last lecture we discussed about different layer, their functionality, topology and different mode of communications. So today we are going to discuss about network devices. What do you mean by that? That means how networks are or how the nodes are connected. They may directly connected with the wire. They have some intermediate devices like hub, router, switch, gateway. Fine. So what are their functionalities? We are going to see. So the first one is hub. So hub, what is the functionality of hub? It is a basic device. Sorry for that. Today, maybe we'll try that we have a shorter class, not that 1.5 hour, almost 45 to 50 minutes, because I'm suffering from fever or dengue mainly. So maybe we will cover the rest of the time in some other lecture. So the function is uh, a basic device that connects multiple computer in a network and forward data to all connected devices. This line is very important. All connected devices. It means what is hub? When hub is, again, you can just consider as a central device, and once sender send the data, that data reach to hub, and hub blindly forward that data to all the remaining nodes. Why? That is called hub. It means hub is not an intelligent device. It not seeing the destination address and it just blindly forward that particular packet into all the directions. Okay, that is the main point. And we use hub at layer 1, that is called, it's a layer 1 device, that is physical layer. Limitation: no filtering or intelligent data transfer, which cause unnecessary traffic. Can you just tell me why it is unnecessary traffic? Because suppose that if I am sending the data to hub and hub forward this data to in all the directions, then unnecessary in some other directions traffic becomes high. That's why it is not using any filtering concept or all other concept. That's the main point. Let's move on. The switch. So what is the functionality of switch? First of all, it is a layer 2 devices. Keep in mind, hub is layer 1, switch is layer 2. Even though in some books, hub, switch, bridge, gateway, router, all they can say it as switch. So it is a switch of layer 2. Now, it connect multiple devices like computer or printer within a LAN. It means, what is the functionality of switch? Connect devices within a LAN, local area network, and forward data only to the intended recipient using MAC address. It means it uses the concept of filtering and it is a intelligent device. That's why it just forward the data to the required destination with the help of seeing the MAC address as a destination part. And you know that last lecture also we discussed, if you want to send the data within a network, then you are within a LAN, I can say you are going to use MAC address. Over the network you are using IP address. So it reduces because it uses the functionality of filtering and it is intelligent devices. That's why it reduces network traffic. That is the main point. Next, bridge. What is the main functionality? It connect and filter traffic between two or more LAN. See, if you want to connect data within a LAN, then you use switch. But if you want to connect devices between two different LANs, then you are going to use bridge. See the difference between two or more LAN segment. Are you getting my point?
Yes, sir.
Sir.
Fine. So again, it's a data link layer, network layer 2 device. So divide large network into small manageable parts. That is the main advantage of bridge. So if I can say, can you just tell me about the hub? It's a physical layer, no filtering, no intelligent device. Talking about bridge, within a LAN, intelligent filtering. Sorry, switch within a LAN, intelligent. Bridge between two LANs, intelligent filtering. These are the key points we have to keep in mind. Talking about router, connect multiple network. Keep in mind. Bridge used for multiple LANs, it is used for multiple network and route data packet based on IP address. That's why it is a network 3 devices, my dear students. Layer 3 is called the network layer. You know the example home Wi-Fi. Next is called gateway. Now see, it act as entry and exit point between different network architecture or protocol. That means suppose that one network uses one protocol, another network uses another protocol. To connect them, we are using gateway. It's a bridge, fine, or entry and exit point. Are you getting my point? So it converts data format because we are using different, that is not so important. That's the main point. Now repeater actually, if I talk about the task of repeater, it amplify the signal. It means if distance between source and destination is large, then signal quality degrades. So that's the main purpose of repeater, to amplify or regenerate or the same signal or the same signal. Fine. That is the main task of repeater. So repeater, we cannot say it connects something, connect devices. Mainly it is used to amplify the signal. Fine. Used in long distance wired or wireless network to prevent signal loss. Whenever the distance between two devices are so long, then strength of the signal reduces. That's why it amplify the signal or regenerate the signal. Are you getting my point? So let's talk about some of the, I think, questions. Which of the following device is responsible for connecting a computer to a wired or wireless network? Any
NIC.
NIC, very good. So now, which device connect multiple computer in a network? Keep in mind, multiple computer in a network, but send data to all the connected devices. Can I say hub?
Yes, sir.
Directly forward the data to all the remaining systems. So hub is the right answer. Next, yeah. Which of the following device connects different network architecture? That is gateway. Fine. A device that connects multiple computers within a LAN. Important is within a LAN. and forward data to the intended devices only to that particular destination using MAC address. Is it switch or bridge?
Switch.
Very good. Switch is the right answer. Which device is used to connect sorry, multiple network and make routing decision? In the routing decision, you already get the hint. Router is the right answer. Fine. So I think you will go. With that, we end up with our first module. Now we will discuss the second module, that is data link layer and network layer. Are you able to see the PDF doc? Are you able to see
No, sir.
data link layer? No. Wait a second. Now,
Yes, sir.
okay. So let's start with our data link layer. So can you just tell me? Yesterday we discussed about the some functionality of data link layer. Can you tell me any idea about the functionality of data link layer?
Sir, physical transmission of data using MAC address.
Okay. One is framing, flow control, error control, access method. So at data
CRC.
link, yeah, at data link layer, we use CRC for error control, right? Yeah,
Yeah,
great.
yes, sir.
Yeah, very good, very good. So that is the main point. Now see, I need to zoom it. Something. Yeah, data link layer. The data link layer is responsible for node to node delivery. Who is responsible for process to process delivery? Application layer of the data within, keep in mind that line is very important, within the same local network segment. Within the same local network segment. It received packet from the network layer. See, if I talk about the center side data transmission start from the application layer, then transport layer, then network layer, and then data link layer. That means data link layer receive the data from network layer and encapsulate them into frame. Encapsulate means we already discussed in the last lecture that whatever the data sent by the network layer, it consists application layer data, header of application layer or some extra information. Then it consists transport layer information. Then also it consists network layer information. Okay. Other than the original data, it consists some other information also. So the whole thing is considered as a data for data link layer. Fine. Are you getting my point? It receive packet from network layer and encapsulate them into frame. Encapsulate means cover into them. Now again my original data size is so much, that's why I need to divide my data into small parts, that is called frame in the data link layer. Fine. Responsible for error detection. So data link layer is responsible for error detection and correction. Means it detect the error, also it correct the error. Framing, dividing the large size data into small unit, that is called frame. Flow control. Flow control means suppose that sender send the data, receiver task is to receive the data. But suppose that receiver is unable to receive the data with the pace, the pace by which sender send the data. Then there is a loss of data. That's why there is a protocol mechanism which flow this control, which controls the flow of the data. Then adding physical addressing information, that is MAC address, to the frame. That's fine. Now it ensures data transfer over the physical medium is free from error and collision because it provides flow control and error control mechanism. That's why. So keep in mind, data link layer provides flow and error control. Transport layer also provide flow and error control. Fine. That's the main point. So interface directly with hardware. Okay, that's fine. Now, that means NIC. We are talking about NIC. Now, the key points. We already discussed. First functionality is framing. Break the bit stream into frames for manageable data transfer unit. Error control. Detect and correct error using CRC. Fine. Next, flow control. Prevent fast sender from overwhelming slow receiver. Fine. Any doubt? Next is physical addressing. Each frame includes sender and receiver MAC address. Yeah, that's the MAC address we used in at data link layer. And access control. Now, see, what do you mean by access control? Suppose because data link layer works within a LAN or WAN only, now all the systems are connected within a LAN. Suppose that. Then who can send the data? Suppose that all the station send the data at the same time. Just keep in mind the idea of bus topology. In bus topology, because or ring topology, we have only one medium, right? One channel. Suppose that all the stations send the data at the same time, then you know that there is a collision. Yes or no? Yes or
Yes, sir.
no? That's
Yes.
why who can share the medium? Who can access the medium? That is also done by data link layer. So this is very important. Data link layer actually divided into two parts. Keep in mind. One is logical link control LLC, which handles the flow and error control or multiplexing. One is media access control, which control access to physical medium. Task of framing and addressing is done at media access control MAC. So keep in mind, data link layer internally divided into parts. That is very important. Now, okay, that's fine. It's a comparison between or a yeah, comparison between network layer and data link layer. Network layer and data link layer provide node to node data transfer. Network layer provide logical addressing and routing. So these are some of the functionality. We will discuss about the network layer, but we know what the framing means, error detection, MAC address, and switches. You can see here. Now see, network layer. So we are not going like in depth in the what are the flow control protocols, what are the error control protocols, how CRC work, because that is not that much important. But CRC, if you know CRC is used at data link layer, that is enough. Now see, network layer. The network layer is focused on the delivery of packet between devices that may not be on the same local network. Now see, in the network layer, we already discussed we use routers whose main functionality is to what is the functionality of the router? What is the functionality of bridge and switch? Router functionality is over the network. Fine. Connect the devices over the network. It determines the best path for data to travel across the network. Now, see, we already discussed yesterday. Suppose that I am the source, you are the destination, and in between us, we have many routers. Okay, so how routers are connected? So I just send the data. That data reaches to the my nearest router. Now, how router knows that to which next router I have to forward these packets, because that router is already connected with many of the routers. Are you getting my point? That is the main key point. That's why it uses the concept of routing. We have some routing algorithm. So link state routing is there. Fine. One more routing is there. That is not like that we are not going to discuss in detail now. But with the router is an intelligent device, keep in mind. It performs some calculations, and based on that dynamic calculation means it changes over and over. And based on those calculation, it forward the data to the appropriate router. So it handle packet forwarding. Yes, it forward the packets. Next, fragmentations. Now see, fragmentations means what here? Fragmentations again means divide the large size data into small parts, small units. That is the fragmentations. But the point is, see, suppose that we have three router A, B, and C. A is connected with B, B is connected with C. The medium by which A and B are connected, suppose that it is some particular wire. Fine. So the capacity of that wire to handle the data is 1500 byte. And B and C are connected again with some specific wire whose capacity is only 500 byte. That's why over the network, if there is a requirement of doing or dividing the packet, that is also done by network layer, and that is called fragmentations. And at the destination side, it reassemble all those segments. That's why reassembly is also done at network layer. Are you getting my point?
Yes, sir.
Fine. So the key points are here at the network layer, we uses logical addressing. MAC address is be there in our system. It's a static address, we can say. But IP is a logical address because right now you are connected with the home Wi-Fi. You have some IP. But when you connect your system to a university Wi-Fi, you have some different IP. That's why it is called a logical address. Routing is done, select optimal path. Keep in mind the word optimal path to move the data across interconnected network. Fine. Packet forwarding, that is the same. Routing and packet forwarding are same actually. Fragmentation we already discussed. And error handling. Now that is very important. That is very important. Now see, can you just tell me from which layer network layer get the data? Can you just tell me? Network
Trans
layer get the data from
transport
transport layer. Very good. So what type of data is sent by transport layer? It sent the data, the original data,
segment.
the information of application layer, some control or some extra information of the application layer, plus as well as it attaches its own extra information. Yes or no? Yes or no? So
Yes,
that
yes.
is the data, that is
Yes,
the,
sir.
or we can call the whole thing data plus application info. plus transport layer info. We can call this whole thing as a, either you can say data for network layer, or you can, better to say, you can use payload. Fine, payload. That is the main point. Right. Now, so error handling. So now error handling is done for what? Network layer also attach its own info. And when these packets forward over the network, these packets are fragmented. So it only check. Keep in mind, my dear student, this line is very, very important. Network layer error handling is only for the network layer info. That is called network layer header. It is not for the data link layer. It is not for the data. It is not for the application info or application header. It is not for the transport layer info, that is transport layer header. It is only check the error related to its own header. Are you getting my point? That's why it detects unavailable routes or excessive conjunctions. That is the main point. Keep in mind, my dear students. So, what are the different protocols used in network layer? Now you can see ARP, Address Resolution Protocol. What is the main purpose of address resolution? So mainly we are using four protocols at network layer. One is ARP, one is RARP, one is ICMP, and one is IP protocol. So these are the four main. IGMP no one will ask you, but that is the key points. So ARP. ARP maps IP address to physical MAC address. That is the most important line. What is the main task of ARP? It map IP address to the MAC address. Are you getting my point? So IP is a logical address, but that particular logical address right now assigned to which MAC address. So it maps IP to a MAC address, my dear students, within the same local network. Critical for transmitting packet at the data link layer when only a device knows IP. Okay, that's fine. But the main point you have to keep in mind, ARP maps IP address to the physical MAC address. Now, reverse of that, we have one more protocol, that is reverse address resolution protocol. It essentially reverse of ARP, that is which maps an IP to a MAC address. It's wrong. It's a MAC to an IP address. Okay, it's a map to an IP address. I'll update it. Then ICMP, Internet Control Message Protocol. Now see the full form of ICMP, Internet Control. It means it send. So last lecture also we discussed about ICMP. It mainly handles the error messages or debugging purpose. Are you getting my point? Yes or no?
Yes.
Yes.
Yeah, that's why. So ICMP is used for sending control message, error notifications, diagnostic functions like ping utility, help to maintain and report on the health and reachability of network devices. So if there is a congestion in the network, suppose that if router drop the packet, why router drop the packet? What is the main reason? If suppose over the network one link is break, so whatever the packet reside in that particular link, all are going to be dropout. So ICMP has to send a message to the sender that you whatever the packet you send that is already dropout, please resend it. So this type of task is done by ICMP. Now IP protocol. IP now internet protocol. We have right now we are using IPv4 version 4, but mainly we have two version IPv4 and IPv6. Now key points for IPv4 is I want to add it. IPv4 is 32-bit, fine, whereas IPv6 is 128-bit. Keep in mind this line is very important. IPv4 is 32-bit, IPv6 is 128-bit. Can you just tell me with the help of 32-bit how many different addresses I can generate? Any idea? 2 power 32. And with 128-bit, 2 power 128, which is a large number. Fine. So IP include both IPv4 and IPv6 version is the primary protocol for logical addressing and routing of packet between device across that is fine. Fine. So for IP, you have to keep in mind two main things. Two version 4 and 6. 4 is of 32-bit, 6 is of 128-bit. Next, IGMP, Internet Group Management Protocol. So it is used by host and router on an IP network to. So can you just tell me what do you mean by multicast? Suppose that I want to send a data to fix some more than one to the more than one client. Okay, then that is called grouping, multicasting. Fine. It is used by host and router on an IP network to establish and manage multicast group membership. IGMP allow devices to join or leave multicast group, enable efficient one-to-many. That's why it is called one-to-many communications. We have mainly two terminology. One is multicast, one is broadcast. Broadcast means if I want to send the data to all the clients, then it is called broadcast. If I want to send the data more than one, but not all the client, then it is called multicast. Fine. That is the main point.
Sir, I did not understand. Can you repeat?
Okay. Suppose that I have the organization, and in that organization, we have total 100 employees or 100 systems. Fine. So if I
Okay.
want to send the data to all these 100, then it is broadcast. Suppose that I want to send a message to like 15 of them, then it is
Hmm.
multicast. If I want to send the data to all the clients, then it is broadcast.
Okay.
Fine. Now, addressing at, we already discussed this. Network layer is responsible for logical addressing. Data link layer is uses for MAC addresses. Fine. Yeah. You can see here the format of IPv address. You can see here. See, IPv4 address. Even though it is not that much important, but still it is of 32-bit. We know that. Now keep in mind this point. It divided into 4 octet of 8-bit each. If it is of 32-bit, if I divide that things into 4 parts. That means each part is of 8-bit now.
Yes.
Yeah. Means in the first octet we have 8-bit, in the second octet we have 8-bit, in the third octet we have 8-bit, in the fourth octet we have 8-bit. Fine. Either if you want to write in the form of bits, can you just tell me with 8-bit, what is the range of the number you can generate? 0 to 255? Yes or no?
Yes. Yes.
2
Yes.
power
Yes.
8 is
Yes.
256, 0 to 255. Fine. So if you want to write in decimal, then again it consists with 4 parts: 1, 2, 3, and 4. But the number of each these 4 things are between 0 to 255 only. Because each octet contain with 8-bit. Are you getting my point?
Yes.
Yes, sir.
Fine. Yeah. Always keep in mind what are the main 2 points we discussed related to IPv4. One is it is of 32-bit, IPv6 is of 128-bit, IPv4 is divided into 4 octet, each of size 8-bit. If we return the decimal form, that highest number is 255. Fine. Now, have you know what do you mean by classes of IPv4? Because this is the advanced topic actually. If you know something, then it's better to discuss. Any idea?
No.
No, sir.
No. Okay. See, my dear students, initially what happened, this IPv4 is divided into some classes. Classes means what? See, at the initial stage, suppose that you are an organization, you required some 10 IP addresses for your organization. So you belong to a specific class because you required only 10 IPs, 10 hosts. Suppose that I have the organization which requires something like 20,000 host or 20,000 IP I required for my organization. So I have one class. I belong to one class, okay? But there is a problem. Suppose that I belong to a class in which each network can contain, suppose that 2 power 16. 2 power 16 is a bit large number. Fine? You know 65535. Almost 65,000, okay? Then suppose that I belong to that particular class, but I am using only out of 65,000, I am just using 10,000 IPs. It means the rest of the IPs for that particular class is for a particular network is wastage. So there is a lot of wastage, and sometimes IPs are not sufficient. That's why at the initial time they divided the things into classes, but then they remove the concept of classes. Right now we are not using the concept of classes. That's why I think it's not, maybe we will discuss it tomorrow. Yes. Okay, my dear students, today we'll discuss these things only. Maybe tomorrow we'll cover some more topics and some extra time, okay? Any doubt till now?
Sir, can we expect something like
Numerical? Numerical?
how many? No, 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 numerical, like how many IP addresses will have this much? Something like the calculation part in this IP addresses will be
No,
there
no,
or
no,
not?
no. See. Okay,
So
suppose
like
that
number of hosts and those things.
Yeah, yeah,
I
something
don't
like
think so. You required to learn these things, but still we will discuss it tomorrow, okay?
okay.